pressure. So we'll be looking at yes, we'll be looking at variation of at rest head pressure. So the first one that we did, we looked at condition where there was no groundwater table, there's no water in it, so it was a dry soil. And so here we are going to look at situation where there is presence of groundwater. Now we have to take some things into consideration. Now in this case, the first thing that we do is that we'll find the lateral earth pressure without the water. So that's the first thing that we'll do. Then the second thing is that we'll find the lateral earth pressure that is produced by the water of the water. Then we add the two to get our entire variation. So basically that's how we will go about it. So let's take some things into consideration. So assuming assuming this is my retaining wall, and this is the water table. No, this is the water table coming. Let me use a blue color to indicate the water table. So this is my water table here. My water table. This is my soil ground surface. And so the soil here will have a unit weight gamma. The soil here will have a unit weight gamma star because it's beneath the water table. Now the height from here to here is h1, and the height from here to here is h2. Now the total height from here to here, we'll call it what h, right? So in this case, we need to find the at-rest earth pressure. Now, in this situation, to our K will be the K naught because at-rest earth pressure coefficient, because the condition is that the retaining wall is what is at rest. So let's see. Let's draw the variation. So this is the whole setup. Let's draw the variation at this side. So I'm going to draw the variation. Now at here, at this point, let me call it point A. It is point B where the groundwater is and point C. So at let me do this. At point A, Z is what? 0. That is Z is our depth. At point A, Z is 0. Now when Z is 0, effective geostatic stress will also be 0, and our at rest earth pressure or our lateral stress will also be what? 0. So at this point, we will plot, if we are plotting, this point is going to be 0. So if you are plotting, this point is 0. Then at spot B, at B, Z is H1. So at B, we will have the Z to be H1. And so our effective geostatic stress at that point is going to be gamma H1. And so our at rest earth pressure or our lateral stress is going to be K naught gamma what H1. So at this point, let me plot it. Hey, bando number. Take the 10 gig. At this point, let me plot it. Is what is K naught gamma H1, right? Then we'll look at 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 C, at C, where Z is equal to H and H is equal to H1 plus what H2. Now, we initially said that in this case, we would take the water out. So in taking the water out, if we want the effective geostatic stress at that point is what is here plus the depth here. So that is going to be our gamma H1, right, plus the effective unit weight times H2. Because we are using effective unit weight is because we are taking the water out. You get now, you know that effective unit weight is equal to gamma sat minus gamma of what? Water. Do you get it? And so at point C, the geostatic stress at point C is going to be gamma H1 plus the effective unit weight H what 2. Remember that we are taking water out. So it's like this is saturated. Why is it saturated? Because of water. So we are removing the component of water so that we will get the soil. Do you get it? Uh-huh. And so at this point, let me plot it also here. Let me plot it. Let's say it's somewhere here. And so from here to here, we would have it. So um, so from here to here, we are seeing that from here to here, we are seeing that it is what? Um, so before that, before we plot, we have to find the at at rest earth pressure. So that gamma prime of H is going to be, you just multiply this one, the you started by K naught, and so it's going to be K naught gamma H1 plus what? Effective gamma H2. Do you get it? So we are going to have something like this. And so if I'm plotting, I'm going to have here to be K naught multiply gamma H1 plus effective unit weight H what 2. So I can join. They are not straight line. They are not exactly straight. You get it? Now I can create a section here and say that this section is the same as K naught gamma H1. And so I can say this section is what? K naught gamma effective H what 2 here. And the two combine to give us this. Now we said that when we take water out, the next thing that we do is to find the lateral earth pressure of water. Do you get it? All right, now let's look at that of the water. Just as the theory. So this was the water table. The water table was from B to where? To point C, right? Now there's something about the water that we need to take notes. Now we know that pressure of water acts equally in all directions. So pressure of water in the vertical direction is the same as the pressure of water in the horizontal direction, right? So pore water pressure is equal. So let me put it here. Pore water pressure is equal in all directions. So the way pore water pressure varies with what? With vertical depth. It's the same way pore water pressure varies laterally. So the way pore water pressure varies vertically is the same way it varies what? Laterally. And in that case, the K naught in the context of the pore water pressure is going to be 1 because what the um let me erase this because pore water pressure in the vertical will be equal to pore water pressure in the horizontal, and we know that K naught is the horizontal stress over what? The vertical stress, and this is going to be 1. Do you get it? And so if the water is the level of the water table and we want at this point pore water pressure is 0, at point C is going to be gamma of water times what? Times that is times the depth. Gamma of water times what? Times the depth. And what is the depth there? H1. So at B we know that um pore water pressure is 0. At point C, pore water pressure is gamma W or Z. And so C at point C, pore water pressure is gamma W times what? H what? H2. So here, if I'm going to plot it, from here is 0, then it comes to what? gamma WHZ. Now, in terms of the lateral, so this is in terms of the vertical. In terms of the lateral, pore water pressure at Z. So let me use this its symbol. So pore water pressure lateral is going to be K naught gamma WHZ. But we said that K naught is what? 1. So it's going to 1 multiplied gamma WHZ. And so in this case, we are going to get only what? Gamma W. And so if I plot, it's going to be this, then that, this and that. So now I have these areas. I have area 1, area 2, area 3, and what? Area what? Area 4. Now, if I want the resultant force, it's simply area 1 plus area 2 plus area 3 plus what? Area what? 4. And I'll get the resultant force. Now, what is area 1? It's a triangle. So half base times height. That is, base is K naught gamma H1 times the height, which is what? H1. Area 2, which is rectangle. So length times breadth. Length is K naught gamma H1. Breadth is what? H what? 2. Area 3 is a triangle. So half base K naught gamma prime H2 times what? H2. Then that of the water area 4 is also a triangle. So half base is gamma WH2, then the height, this height is what? H2. This height is H2, this is H1. And the total height is H. So times what? H2. And so let me clear this section. Let me clear this section. And so if I put them together, if I put this together, so let me put an arrow here. Let's see, we are continuing here. If I put them together, I'm going to get a 1 over 2 K naught gamma H1 squared plus K naught gamma H1 H2 plus 1 over 2 K naught gamma prime H2 squared plus 1 over 2 gamma W H2 also squared. So this is how we find the total, and this is equal to the resultant earth pressure. Now you see these shapes. This is a composite shape. So in order to find where this force will act, we need to take moment at the base of the retaining wall. So we take this one, take moment, take this one, take moment, take this one, take moment, and it is equal to the moment that the resultant, that is varigon. Remember varigon? Uh-huh. So yeah, we will take a question and we will see how we will go about it. I think it was an assignment. We'll look at it and see how we go about it.